In this quick video, I want to talk about cutout casing HDA node. The idea of the node is to create a transition between two sides of a wall. In this example, I have used it a couple of times to create this kind of a trimmings around the exterior and interior wall of the building. So there are multiple styles that you can use, and it also can be used for something like a wall for the entries and for the windows or whatever cutouts you have for your building. And you can also use different styles. In this case, with the type with most options is the typical rectangle type, that you can then control the individual parts of the trimmings on the inside and the outside. So both of them are individually controlled, that you can switch between. But you can also, if you do not have an exact rectangle, you can use just a simple sweep node to control the profile around the irregular shapes, in this case, like a rounded square rectangle in both of these. And then there's a third one, which is kind of a more basic one, which is kind of like I called it the path joint, which usually called, which basically means that where this ends, the other one is basically just connected inwards like this. So it's a little bit simpler, which you would maybe see on the simpler buildings, but I still wanted to add it because it is very common. Have these basic cutouts, and from the Boolean node, I have made sure that I have saved the cutout groups that usually comes from when I do my cutouts with some simple boxes. The Boolean node has ability to be inside a option to save this group, and this group is ideal to be used on the cutout casing nodes. So in this example, what I'm saying, go to the setup and say, actually, I want to use my group, which I have marked as a door. And now we can go ahead and start adjusting these values. So first of all, let's go to the side A. So these sides are divided into parts to know which tab you should control when you are starting to edit the look of the trim on the both sides. In this example, A is the outwards. So let's go to the A tab. Let's take a look at them. So we have our top. So the top is considered this part of the part. The red one is not. So the red one, the very top one is called the cap. So we can actually disable the cap. We don't need it to showcase the rest of it. So the top of it is going to be under the top tab. So there's a bunch of options that you can play around with. The most important one is the ability to extend the polyline that is used to source this kind of a profile, and the actual profile that you can change, that allows you to create different looks for your trims around. So you can see the shape of it is actually controlled by this trim, by this sweep profile shape. So you can just go ahead and play around with it. Then you can also scale the actual profile. So if you want it bigger or smaller, you can, a bunch of these options are available for you. And then at the end you have bevel options. The beveling is kind of important because you want to maybe make it a little bit softer. So you can bevel the actual profile, which means this curve is being beveled, and then the beveling of the caps, like this. And the same options are available for all the parts of the rectangle style. So this is considered a rectangle style. You can go to the sides, again, change the profile, the sizes, and the bevels. So that's not very exciting. So the bottom is a little bit more sophisticated because there are different options for your bottom trim, which I'm going to talk about on the other nodes. Let's talk about the cap. Let's enable our cap, and the cap is just going to be placed automatically on top of your top trim. And again, you can change the sizes of it like this. You can cap scale, you can control the profile, and then there's a bunch of beveling options for the profile trim and for the corner trim, which is basically considered this one, the two corners that are outwards. And all of these options are copied on the other side. So if you say, okay, I actually want to make these trims on the other side, go to the B side, select your style, select your rectangle style, and you can see now you have your options, basically all the same options to do on the other side. But in this case, I actually want to keep it as a sweep option for the other side. So let's take a look at the other side sweep option. So all of these parameters are mirrored across both sides. So if you go to the sweep, you can control the size of the sweep, the thickness and the width of it, the profile, and then just the bevels on all that. The unique parameter for the sweep option is that you can have an ability to split the corners. So the split corners, this is interesting because it will take all the splits between the polyline, underline, polyline sourced. It's going to split them at that. You can see in this case I have something like this. I can split it to make it maybe more of a look of when the pieces of wood are actually connected together. So that's split corners. So the rectangle and the sweep is pretty straightforward. Now for the unique sweep type, that is only under the A option, because it's basically going to replace the B option also, side B also, is the butt joint. And the butt joint is, as you might look, it's very simple, it's just a board across like this, and that's it. But it's also going to replace the middle part that's also being created. So if you take a look at something like a rectangle type, since the profiles are actually only covering the over, so we need also a part when we create our casing. We also need a part that's going to connect both of these casings. So the idea is that we have also a middle part of the casing. So if you have selected your side A and B, go to the middle. Let me go ahead and disable this. You can disable the middle. You can see in this case the only sides A and B looks like this. And if we enable middle, that means that we want to actually connect them here. And internally, HDA is going to do a little bit of a value adjustment. So the value adjustments are controlled by this precision offset. It's just set to very small amount. So this is done to prevent any Z fighting between the casing and the internal and the source polygons that we use to create the casing. Because if our middle part of the casing would be at the same location as this one, we would have ugly intersections. So this is where the precision offset comes in very handy. You can see if you start to move it, you will notice that casing goes very slowly inwards. So this shouldn't really be a very big value, because you want to make sure that the casing is at the location of our original source site, but does not intersect with the original geometry. So this is where the reverse side, where the precision offset comes in handy. And the reverse side is just as you might imagine. We can reverse the sides of the casing like this. That's pretty straightforward. Now let's go back to the middle. So let's go ahead and take a look at the middle. So the middle, if we enable the middle, we can split it at the middle, because the idea is that you might want to apply different materials to the both sides of the casing. So let's say if you have like a window, and the window has different materials on the both sides, ability to split the geometry and then later on apply different materials can be very useful. Then we have ability to extrude, so how much you actually want to extrude your casing inwards. So this shouldn't really be a big value because most of the casing at the end of the day would be covered by the walls and by the actual trim. So the extrude is optional, however you want it to be, because there are different options. So the bevel is pretty straightforward. You can bevel your casing, the middle part, and how many divisions you have. The interesting idea, the interesting ability for the rest of the casing is extend it. So sometimes when you have your geometry, you have like your walls are not like these perfectly straight polygons. You might have something like you might want to generate some offset for your from the trim and from the original geometry that you source your casing from. And then the idea is that you can actually extend either A or B side of it. In this case, you can take a look at it. If you say extend A, it's going to move outwards, create the actual middle part bigger, but also going to extend the casing. So this can be very useful when you need some fine adjustments for size of your casings. And it's basically done to the either for A and B on both sides. Bottom part of the casing has two available styles, so you can use a window sill or a trim. So the trim is basically the same thing as a top part of the as a top part of the rectangle style. So the interesting part is the style, the trim style. The interesting part is the window sill style, which is very similar, but the idea is that we can bevel the sides of the windowsill, and this is done by the bevel corner option. And then there's also bevel. We can bevel it like this. And so the profile is disabled because the profile doesn't work on this kind of on the windowsill geometry, but you can still change the size of it, and then you can also extend it like this. And for the trim, it's basically is going to enable all of these, and some of these parameters are reused for the all the parameters. We do not introduce any new parameters. We just disable some of them for the windowsill or the trim and all of that. And the trim is basically the same thing except for ability to bevel the corners, which we can't really do with the sweep shape. So you kind of have to choose what kind of corners you want, but it is very useful to have the windowsill option to have these kind of rounded corners. So it looks actually really nice with these corners. Talk about the UVs very simply. So I have tried to make this HDA node as fast as possible. I am using a compile block. That means it's going to be pretty fast even with multiple geometry pieces. And if you want to make it a little bit faster, when you are actually creating your trims, your casings, you can actually disable the UVs. Since UVs does take a little bit of a processing time, you can disable them and work on your trims on how they look and then enable UVs. The UVs are very simple. We can offset some of these. You can offset randomly your UVs. You can seed them. You can scale them. And by default, the default value should actually work pretty nicely with the texture, but all of those options are available. And one last thing that I want to talk about is how the tool actually figures out the direction of the casing and how it actually creates all of these casings for all the different geometry types. So the idea is that we actually have to give it a good direction of the casing. And by default, you saw that I have not given any attribute values for it because by default, the HDA is set up to use the point number of the casing. So internally what this option does, it takes the input geometry, it figures out the internal edges of this geometry, it basically deletes and use the first one of these poly edges to create a direction of the casing. In this case, you can imagine that if this geometry has been left like this, if we input this geometry, it's going to figure out that this is going to be, for example, this is going to be the direction of the casing edge group polyline, I guess. And it's going to take a look at the point order and figure out the direction of it. It's going to take from the smallest to the biggest point. It's going to create a direction. In this example, the direction would be this on this side, like this. So this is how the tool automatically figures out the direction of the casings. So this is why it says that this is a point number direction. But you can actually give it an attribute if you have an attribute on it. So in this, you can see I have broken the tool because I have no attribute that points to the direction of the casing. And the most, in this example, the casing direction would be the normal of the wall. If I would have like an attribute on these primitives that points outwards to the wall or inwards, then I could also provide it with this attribute value. Or I could also give it a vector, which is good for a single, for something that is for a single cutout. So that's not very useful for me. And by default, this should always be by point number because it's going to automatically figure out the casing. So it is important that your cutouts are completely equal on both sides. So we can't really have like an angled cutout for any of these walls because this is going to be kind of a backbone of the direction of the geometry. And if you want your casings to match walls, it is important to use a normal direction as an alignment for your cutouts. They should be exactly like that, exactly match the cutouts to exactly match your walls and all of that. So that's one important thing, but it should be, as long as you're careful, the tool actually figures out many situations. So yeah, I mean, that covers basically everything I wanted to talk about in this node. How to set it up. In most cases, you want to give it just a group that you want to create your casing from, but you can actually do it also manually. In the example, let me go ahead and select it like this. These three geometry is going to work just fine because internally it's going to use the connectivity of it like that. Yeah, I mean, that's basically it for this tool. I hope you find it useful and see you next time.